electrons. Yeah.
It's flow of electrons, or basically you can say flow of charge. So if electrons starts to flow, then only you can experience current. And even I have explained you using a circuit that it has battery, there's a switch, there's a bulb. Okay. So what happens is, what's the basic work of a cell or a battery?
Huh?
What's the work of a battery? Why do we use battery or cell?
So there are two. There are positive charges and negative charges, and the positive charges repel each other, and negative charges repel each other. So the battery gives electricity to the circuit so that it'll light the component. It'll give electricity to the electrical component you put within the circuit.
So basically, cell gives energy. It's not it gives electricity. Actually, it gives energy. That's why electrons starts to flow, and we can experience electricity. So the work of battery is to provide energy. That energy is provided to the copper wire or any conducting wire that we are using in the circuit, and then the electrons starts to flow. Because of that energy, they starts to flow, and that is this flow of current is then known as what? Current. Flow of electrons is
Yeah.
basically current. So definitely, like if you want to run, or suppose there's a box on the table and you want to move that box, what you do? You give a push. So it's what? You're supplying energy from your side. So same thing as here, like if there's analogy. So that's a cell that gives basically energy, and that's why the electron starts to flow. Otherwise, without the energy, it's not possible for the electrons to flow. Okay. So basically, cell provides energy to the electrons. Then, after taking the energy, electron starts to vibrate, and this motion of electrons or transferring energy of electrons or flow of electrons is basically what? Current. Okay, that's basic definition. Now moving on to the formula. What's the formula of current? How we calculate the current?
So it's V equals IR.
That's the relation. That's the Ohm's law. Uh,
So
I'm, I'm talking about the formula of current. How to calculate current?
I equals V over R.
That's a relation between resistance, potential, and current. This is Ohm's law. Like V equals Ri or I equals V over R. That's basically Ohm's law. But a separate current formula that relates the charge with current. The basic definition. Because I told you flow of electrons. So from that definition, what's the formula of current? Tell me. What's the formula?
So the formula of um, so is it the formula of electricity or current?
Yes, that relates to the very first formula. If you have notes, if you see, it's the very first formula that connects electrons and current.
So I equals Q over T.
Yes, that's correct. So, like if the question is given that uh, the charge is something something coulomb and in given time period it flows, so what's the current? So you just know that what's the formula that shows you the relation between a charge and current or time and current. Okay. Now you tell me what are the units of these
Pardon?
units. Like if you want to write the magnitude, it should have some units.
Oh yeah, okay. So
What's the unit of current?
the unit of current. Um, um, is it? Oh yeah. Is it A?
Amps. Yes, not amperes. And charge
Amps. Yeah.
and unit of charge.
Is it ohms?
It's coulomb. Ohms
Oh yeah,
is
coulombs.
unit of resistance.
Okay.
And what should be the unit of time?
Time seconds.
Yes, that's correct. So like if in a question it's given as calculate the charge when 12 amps of current flows for 2 minutes. When 12 amperes of current flows for 2 minutes, you have to calculate charge. How can you calculate this?
Well, and flow for 2 minutes. What is the charge? Okay. So the charge will be 24. No,
Correct.
sorry. Yeah, yeah, 24.
You yourself told me that if the unit of current is amperes, the time should be in seconds. Their time is given in minutes. So you can do just 12 into 2 directly. You have to convert the minutes into seconds first. Okay.
Okay.
That means it's 2 into 60 into 12. If you convert the minutes into seconds. So 1 minute equals 60 seconds. So 2 minutes equals 2 into 60, 120 seconds. And then 120 multiplied by 12 will give you the charge. This is clear?
Yeah.
Okay. Next is potential difference. How can you define potential difference?
The potential difference is when the so um so when the so it's like the difference of electrical potential between 2 points.
Yes, that's correct. And how can you define potential? Like I have told you that a battery has two plates, one at higher potential, one at lower potential. Whatever be the difference between those two potentials is your potential difference. But in a definition, how can you define your potential?
So it's potential the amount of like energy it has in one component.
Yeah, like the definition, if you remember, I have drawn a diagram of positive charge. It has a field around it, and you have to move
Oh yeah.
another positive charge. That's potential. So how can you define that potential?
So potential is so potential is so it's the energy mass in a gravitational in an electric field.
It's like the work done by a charge in order to move from one point to another point in a field. That's potential. Remember? Like I have written also. Okay, so let me write this one. So it's amount of work done it's amount of work done in order to move
wait for 5 minutes after the class to read it and reinforce it. Again, after coming, you should practice waiting to run the and pick up and start again. Next week, she'll ask you, what is that? What is
This is clear. Potential, it's amount of work done in order to move a charge in a field from one point to another point. Okay,
So that's potential difference.
that's potential or potential difference. Both you can say. Both have the same definition.
Okay.
So you keep on writing. I think it's better if you have some copy with you, and whatever I used to tell you, you just keep on writing that regularly. Okay, so that whenever I ask you something, if you open the notes, it will be much simpler for you, right?
Yeah.
So I haven't written that from one point to another point. Just write the definition. It's amount of work done in order to move a charge in a field from one point to another, or it's better if you write amount of work done in order to move a charge from one point to another point in a given field. Here you just have to write from one point to another point. Okay,
Okay.
that's potential difference. Now you tell me what's the unit of potential difference?
Um. So the unit of potential difference is
Unit of potential difference.
um. Is it what do you call it? Oh no. I'm not sure.
It's
I
volts.
had it. Volts. Oh yeah, that's the one.
So like if you see a battery, on the battery it's written as it's 12 volts of battery, 14 volts of battery, 20 volts of battery. Its rating is given there. So that's volts. That how much energy it can provide. Basically how much voltage it can provide. Okay. So you just have to remember that unit of potential difference is volts.
Volts.
Yes. Now the next is Ohm's law. You tell me what's Ohm's law.
So Ohm's law defines that the resistance between two components.
Like what's a statement of Ohm's law? It's a law, so it should have some statement. So what's a statement
Oh
of
yeah.
Ohm's
So so it's a law that states that um the electrical current is proportional to voltage.
Yes, that's very correct. So Ohm's law is basically what? That electric current is directly proportional to the potential difference. Okay, that means if you keep on increasing the potential difference, you will get a higher current. Okay, and if you
Yeah.
decreases the potential difference, you get a lower current. So they share a direct
No.
relationship between. Right now, if I remove a proportionality sign, I have to introduce a constant, and this constant is resistance here. So I equals VR. V equals IR. So you get V equals IR. So this is your potential difference.
Yeah.
This is the
Okay.
electric current, and I is what?
R is for current and R is for resistance.
Yes, and what's the unit of resistance?
Pardon?
What's the unit of resistance?
Oh, resistance. And it's um, The unit for resistance the unit for resistance is ohms.
Yes, ohms.
What does SI stand for?
SI.
Yeah, because that's a unit for one of the
Okay, SI.
components.
Okay, it's an international system.
Pardon?
International system, SI unit, that is acceptable everywhere. SI unit.
Okay, international system.
Yes. Okay, now one question. You have to calculate resistance if the potential difference across a battery is 12 volts and it's giving a current of 24 amps. Calculate the resistance.
Okay, so potential difference is 12 volts. Okay. So, is it is to the resistance?
If you use a formula, you put 12 in place of V, 24 in place of I,
Oh, okay. So
then resistance equals
resistance equal um, 9.
tell me.
So um, will that so resistance will equal
Okay, it's a simple mathematical. You tell me, how can you calculate this one?
wait
2x equals 4. What's the value of x?
so yeah, x will equal 0.5.
Yes. So how you have done this question? By dividing both the sides by 2. Same thing you have to do here. Dividing both the sides by 24. If you do this, here you get only R, and here you get 12 divided by 24, which will give you 0.5.
Yeah.
Okay, now the next question. You have to calculate the current if the potential difference across a battery is 100 volts and resistance is given as 25 ohms.
Mm.
You have to calculate current.
Okay. So 25. So current will be um 4 amps.
Yes, that's correct. So this is your Ohm's law. Now, if we plot a graph of Ohm's law between V and R, so it's V versus I, sorry. So it's V versus I. You tell me how this graph looks like if it's V equals RI. How should it
So
be?
V equals Ri.
Yes. So how can you plot this graph? How does it look like?
So the V equaling potential distance and Ri equaling current and resistance.
Yes.
So you could say that that the amount of current and resistance put together would be equal to the potential difference.
Yes, that's correct. But if you have to plot the graph between V and Ri, how does it look like? Okay, I'm just giving you a hint. It's V equals 2x. If a graph is y equals 2x. Can you plot this
Yeah.
graph y equals 2x?
So y equals 2x. So a single line in the graph going horizontally, no, not horizontally, vertically, will be 2x.
If the equation is x equals 2, right? Then it should be a
Yeah.
vertical line passing through 2. But this is an equation relating to different variables. This was the equation of just one variable where your y is basically what? Different and x remains the same. But here it's y equals 2x. It's an equation relating to different variables. Now you first tell me what's the method of plotting a graph? Like in mathematics, if you plot a graph, how can you plot a graph?
So plot a you can plot a graph um, so by putting a coordinate in the x-axis and matching it up with the y-axis.
Yes, the same, definitely. So like if you put y equals 0, you get x equals 0, you get y equals 0. Same as if you put x equals 1, you get y equals
Y equals 0.
x equals 1. In this equation, if you put x equals 1, what's the value of y?
2.
Yes. X equals 2.
Okay, so
Okay, you tell me x equals 2, so what's the value of y?
1,
X equals 2. If you put x equals 2 here, what's the value of y?
0. Y equals x equals 2.
No, no, wait a second. It's y equals 2 times x, right? And if you put x equals 2, that means in place of x, if you put 2, what's the value of y? That I'm asking.
Y equals x.
Like it's in place of x, you have to write 2 like this. 2 times 2. Like this I'm saying. Then y is equals to?
Yeah.
So what's the value of y? 2 times 2 is?
4.
Yes. Now same, if I put x equals 3 in this equation, in place of x, if I write 3, what's the value of y then? Tell me.
Um,
In place of x, you have to write 3. Just like I have put the value of x as 2. Same you have to do. In place of 2, you just have to write 3. Replace. Then what's the value of y?
so y would be 9.
And how it's 9?
Because you're replacing the x with 3 and 3 times 3 will equal 9.
3 times 2 is 6. Like in place of x you have to write 3. And 2 remains 2. So 3 times 2 will give you 6.
Yeah.
Okay, just you tell me why, like what's happening? Why it was 3 times 3, not 3 times 2. Where is the doubt? In this, if you have to
Because
plot a graph, where you are facing problem, so that I can clear you.
you've got
Tell me if you have any doubt,
so,
I can clear you.
so x would equal to 3. So then y would equal to 6. Because you said you had to replace the x with 3 and 2 times 3 is 6.
Yes. Is it clear?
I don't get where you got 3 from.
3 we have assumed it from ourselves. Whenever we plot a graph, what we do is in the given equation, if it's y equals x plus 2 or 2x or whatever, what we do is we draw a two different columns. It's one for y and one for x. We have to take the values of x. It's up to us. We can take any value of x. Either we can take 1, 2, 0, okay, and then we have to put these values in place of x and get the corresponding values of y. Just like if x equals 1, if I put 1 here, I get y equals 4. 3 plus 1 is 4. Then x equals 2, so it's 3 plus 2, it will give me 5. Now when x equals 0, so in place of x I'll write 0, so 3 plus 0 give me 3. And now I have ordinate pairs, so it's 0, 3, 2, 5, 1, 4, and plot these on the graph and join all these points. This will give you a curve. Okay, like it's in
Okay.
mathematics, if you remember, like it definitely you have done questions on these. So that's a method of plotting graph. So okay, leave that as of now. When we'll do the questions of that, I'll explain you at that time also. As of now, what you have to remember is that graph between V and I will give you a straight line like this. Okay?
Yeah.
And whenever you do V over I, that is you find the gradient, you always get the same constant value, and that is equals to resistance. So resistance is equals to V over I. Is this clear? Only
Okay.
now, as of now, you just have to remember that the graph between V and I is a straight line passing through the origin, equally inclined to the origin. Okay.
Okay.
Now the next is not always equally inclined. It's just it has a different inclination, but it's basically a diagonal line that passes through origin. That's the graph between V and I. Okay. Next is that it's not necessary that all the conductors follow the same rule, follow the Ohm's law, or all the materials follows the Ohm's law. It depends on different material. Those conductors that follows the Ohm's law are ohmic conductor. Now, following the Ohm's law, which means it's not necessary that if you're using a different wire and if you keep on increasing the potential difference, we'll get a elevated current. It's not possible for all the type of conductors. Only those conductors in which you can apply Ohm's law are known as ohmic conductors, and rest of the conductors where Ohm's law doesn't follow are known as non-ohmic conductors. Is this clear?
Yeah.
So tell me, what is ohmic conductor and what is non-ohmic conductors?
Pardon?
What is ohmic conductor? What is non-ohmic conductor?
So, ohmic conductor is um, it's like any conductor of which the current is a straight line passing through the origin.
Yeah, or you can say those conductor that follows Ohm's law. Okay, that follows.
Oh, so I can say it's a conductor which follows Ohm's law.
Yes, on which Ohm's law are applicable is applicable or that follows Ohm's law are called ohmic conductors, and you keep on writing, right? So just heading should be ohmic conductor, and you have to write a definition that those conductors that follows Ohm's law are ohmic conductor, and those that don't follow are known as non-ohmic conductors. Okay.
Wait, could you slow down because I'm trying to write this
Okay. Okay.
information in my.
Yes. Yes. So the
So,
conductors that follows Ohm's law
the ohmic conductor
are those
is a conductor
that follows Ohm's law.
which follows
Ohm's law.
Ohm's law.
Yes. And those conductors that don't follow Ohm's law are known as non-ohmic conductors.
So the conductors that don't follow, so non-ohmic conductor is is a conductor which does not follow Ohm's law.
Yes, that's correct.
Okay.
So,
Okay.
and how can you describe me the relationship between V and I? By the graph, what can you say that they are proportional? How? What's the relationship between these two? Tell me. By looking at the formula, how can you describe its proportionality? How they are proportional to each other?
So so IR would so in the graph there would be some plots that would be same along the straight line.
Yes, so you tell me how they are proportional to each other. That's only you have to describe me how they are proportional to each other. Which proportionality is there that is connecting these two variables, that is potential difference and current, how they are proportional to each other? Is my
So
question clear?
potential, yeah,
Yes.
potential difference and current. Potential difference and current. Potential difference and so what would happen would so what the proportional difference would be is that the amount so the amount
Okay, let me tell you. The proportionality is direct proportionality. That's how I was asking. Like they are directly proportional to each other. That means if you keep on increasing one variable, the other variable keeps on increasing. If it's like V is inversely proportional to R is equal to V 1 over r. That means that they are inversely proportional to each other. That means if I increase potential difference, the resistance keeps on decreasing. Or in place of I, r, if I put I, so I can say V and I shares a inverse relationship. One increases, other decreases. That means the inverse relationship. But since we have already written that according to the Ohm's law, when potential difference increases, the current also increases. That means V is directly proportional to I. That's the Ohm's law, right? So when V is directly proportional to Ohm's law, or we can say Ohm's law states that potential difference is directly proportional to current. So the question
Okay.
is, what's the proportionality? What kind of proportionality is shared between potential difference and current? You have to answer it's direct proportion or direct proportionality. Clear?
Okay.
So this is about Ohm's law. The next topic is power. So in
Wait, could
mechanics,
you
yes, yes.
can you bring the previous slide that you had? Because I'd just like to take
Okay,
a pic.
okay, I have actually deleted. Rather than moving on to the next page, I have deleted. Okay, you just tell me what you have to write. I'll write it again.
The graph and the
Yes,
and ohmic non-ohmic conductors and ohmic conductors.
yes. So this is a graph, and this is the graph of what? Ohm's law. And ohmic conductors are what?
Ohmic conductors are conductors which follow Ohm's law.
Yes, and non-ohmic are?
Or conductors which don't follow
Yes.
Ohm's law.
And Ohm's law is V is directly proportional to I, or V equals R. So because of its their direct relationship, we get the graph this one. Okay. So that's the main thing you have to draw, the graph and the Ohm's law.
Okay.
Now next is power. So in mechanics also, you definitely know what's power, energy. So how can you define me power?
So, so you asked me to define the meaning of power.
Yes.
So, power is like a form of energy that that we that we use. So, power is the rate of doing work.
Yes, rate of doing work or rate of change of energy, or how
Yeah.
energy is changing with respect to time. That is power. That's very correct. So if we have to write in formula, in form of formula, we'll get E over T. That is energy divided by time. That's a formula of calculating power. And how
What
can,
about
yes, yes.
I uh, in the book that I read about power, there was power equals amount of work over elapsed time, and
Yes,
there's a T next to the triangle.
yes, like energy or work done. It's the same. Like without the energy, it's not possible to do any work. So whatever the energy is done is, or how the energy is transferring is due to the work done. So you can say work done over time or energy over time is same. Both are joules. Both have the same unit, that is in joules. And also the thing is, if I have energy, I'll be able to do some kind of work. If I don't have energy, how can I do the work? Clear? So basically,
Yeah.
if energy is transferred, it's basically by work done. So if I have energy of 10 joules and I want to consume that 10 joules of energy in running, so running is my work done, but the same amount of energy is converted into that work done. And that's why you can say either energy over time or work done over time are the same. Okay?
Yeah.
Okay. Now, energy transfer in current electricity. Energy transfer is basically what? Potential difference multiplied by charge.
Yeah.
That's energy transfer.
So energy transfer is the
Potential
potential
difference
difference multiplied by charge.
Yes, that's correct. Multiplied by charge. That's energy transfer. In an electric circuit, how much energy is transferred you can calculate by multiplying these two variables.
Okay, so
I'm giving you one question using the same formula. It's given as you have to calculate how much energy is transferred when potential difference of 120 volts because of 120 volts a charge of 2 coulomb is flowing every second.
okay, so 120 so would it be 140? No, 240.
Yes, 240, that's correct. And what's the unit?
Two
Unit of energy transfer.
um
I recently told you the unit of energy.
oh so the unit is joules.
Yes, that's very correct. So unit of energy is joules.
Yeah.
Okay. Now energy transferred in a given circuit is given as 1000 joules.
Okay.
If a charge of 20 coulomb is flowing, calculate the potential difference.
20 20 see, so 1000 J is equal to 20. Would it be equal to would the voltage be 5?
And how it's 5?
No, not 5. Um 50.
Yes, that's correct. It's 50. And what's the unit?
50 voltage.
50 volts. That's correct.
50
Okay.
volts.
Now, if we put the same formula in power, so power is what? Energy over time.
Yeah.
And what's the formula of energy transferred in an electrical circuit?
What's the formula for energy transferred in a circuit?
Yes.
Okay, so it is energy over time.
Uh, Power is energy over time. What's the formula of energy transferred in an electrical circuit?
Oh yeah, so energy transferred is voltage multiplied by current.
Yes. So it's voltage multiplied by current divided by time. Now you tell me, what is Q divided by T? Q divided by T is what?
So that's current over time.
Charge over time. Q over T is charge over time. What is charge over time? Equals.
Charge over time would equal to volts.
Q over T is what?
Um, um, Power.
Q over T is current. Remember, I've told you what's the formula that connects current and charge. That's I equals Q over T. Point clear? You just keep on writing. Whatever I'm writing, just keep on writing, okay? Otherwise, you'll forget this. So Q over T is I. So in place of Q over T, I can write I. So from here, I can say that power is equals to VI. Now you tell me, is this clear?
Yeah.
So first you have to write the definition of power, that is the rate of work done is power, and formula wise it's energy over time. Since energy transfer in an electrical circuit is voltage multiplied by charge, so that's why we have replaced E with V times Q divided by T, and also Q divided by T is I, so that's why we write I in place of Q over T, and the formula for the power in an electrical circuit, power given in an electrical circuit is V times I. Clear?
Yeah.
Okay, one question. A charge of 20 coulomb flows for 10 seconds in a given circuit. If the potential difference is 100 volts, calculate the power in a given circuit.
So 22. Power is so power is 200
Yes, that's correct. It's 200. And also, what's the unit of power?
joules.
It's a unit of energy. What's a unit of power?
So the unit of power is joules.
Joules is the unit of energy. Don't get confused between the units. Energy and work done has unit joules, whereas power has unit watts. W-A-T-T watt. Watts. Okay?
Oh, what? So power unit is volt. No, is
Watt.
watts.
Yes, watts.
Power unit is watts. Yeah. Okay.
Okay. Now I'm uploading some questions, and these questions are from homework. Okay, so whatever we have done
Okay.
here in this class, the questions are based on these concepts.
Okay.
Okay, this one. What you have to do, you just have to take a screenshot.
Okay. Okay. So,
You have taken?
um, yeah,
Okay.
I've taken. Yeah.
Okay, so I'm uploading the next one.
Okay. Let's-
Take screenshot of this one.
Okay. Yeah. I have.
Okay. Now I'm uploading the next one.
How am I supposed to know which of these is not a type of lamp?
Uh, the question that I've uploaded, the previous one, right?
No, no, no. It says which of these is not a type of lamp? The one you just uploaded now.
Okay, so that I'll explain you in the next class. What you have to do, whatever we have done in this class, you do those questions, and rest of this filament lamp and these questions we'll do in the next class. Okay?
Okay. So I should do the first two pages you've given to me.
Yes, and in this also, like you can solve question 5th, the one that is written. You can do question number 3, you can do question number 5. Okay,
Okay.
so these two you can do.
Okay.
Okay, I'm uploading next.
Hello?
Yes, yes, actually I'm uploading the next page.
Oh,
Okay, this one.
so yeah, I've
Okay, now I'm uploading
wait,
next one.
wait, no, 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 wait 1 second. Is this the same one that you've kept on the board?
The same one, the question, the question 6.
Have you have you changed this?
Like your, wait a second. The previous, what's the question? That we have done those questions on board that you're saying?
No, no, no. I hadn't screenshotted it, and I did it before, and I did it in the wrong place. So I was just wondering what you brought up now. Could you bring it up again?
Okay, so you want me to upload the previous one, or you're saying that I have uploaded it again?
No, I want you to upload the previous one. Okay. So this is the previous one.
No, this is the next one. The previous one I'm just uploading. Wait a second. Take the screenshot of this and I'm uploading it.
Okay. It's just the one.
No, it's uploading. Okay, this is the one.
Okay. Is there anything else that?
Okay, these questions you have to do. So what you have to do is just keep on revising whatever we have completed in this class. Revise that and also do these questions. Okay?
Okay.
Okay then. Thank you. Bye.
Okay. Yeah. Bye.
You are currently the only person in this conference.